Okay, let's get into this. We're doing a deep dive today into the global market for, well, a chemical compound you might not hear about every day, but it's really important. Pyrrole.
Mm-hmm.
We're basically using the report Global Pyrrole Market Trends and Projections to 2033
Mm-hmm.
as our guide here,
Mm.
trying to map out, where things stand and where they're heading.
That's right. And pyrrole, the source calls it a fundamental heterocyclic compound. So think of it like a basic building block molecule. It's got this ring shape with nitrogen in it, which gives it some unique chemical abilities.
Right, and those abilities are key. The report really points out its crucial role. It's used as a base for making some really important stuff.
Yeah, like biologically active molecules, think medicines, also vivid pigments, and even organic conductors.
Organic conductors,
Mhm.
right. Those materials that conduct electricity but are carbon-based, not metals. Super interesting. So you see it popping up in pharmaceuticals, agrochemicals, specialty chemicals.
A pretty wide range.
Exactly. So our mission for you listening is to unpack the key trends from this report.
Yeah.
The market sizes, future projections, all that.
And the big picture, definitely showing some significant growth.
Absolutely. So the source shows the global market was, let's see, 255.6 million USD back in 2021.
Yep.
Okay. But then, check this out, there's a really notable surge mentioned.
Oh, yeah.
It jumps to 330 million USD by 2025. That's a pretty sharp increase in just 4 years.
Wow, yeah, it is. And that climb is set to continue, right? The projection for 2033 is 550.3 million USD.
Mm-hmm. And across that whole period, the report calculates an overall compound annual growth rate, the TAGR, of 6.6%.
6.6%, okay.
Which, for a specific chemical market over a decade, that sounds like pretty healthy, sustained demand, especially given its specialized uses.
Definitely.
Now, where it gets really interesting, I think, is when the report breaks it down by region. That's where you see the different dynamics playing out.
Okay, yeah. Where should we start? North America. The report says it holds the leading position globally.
Right. So North America. Its sales revenue was 103.9 million USD in 2021. That grows to 131.6 million by 2025, and the forecast hits 210.4 million by 2033.
Okay, big numbers.
And within that, the U.S. is, well, clearly the dominant force.
Makes sense. The U.S. numbers were 71.2 million in 21, then 89 million in 25, and projected to hit 137.8 million by 2033.
And the reason? The report links it mostly to their well-established pharmaceutical manufacturing and just a robust chemical industry overall.
Yeah, that tracks, given pyrrole's use in making drugs.
Exactly. Canada's also showing solid growth, 22 million in 21, heading towards almost 48 million by 33. But Mexico, that's kind of fascinating here.
Oh, what about Mexico?
It shows the fastest growth within North America started at 10.6 million in 21, up to 14.1 million by 25, and projected to reach 25.1 million by 33.
Huh, interesting. So faster growth rate than the U.S. or Canada.
Yeah, seems so. The report connects it to expanding chemical synthesis and industrial applications there. Maybe new plants or R&D needing more pyrrole.
Could be. Okay, interesting dynamic within the leading region.
All right. So, okay, let's shift gears. Across the Atlantic to Europe.
All right, Europe. It's the second largest market overall. And it shows a pretty consistent expansion, growing from 78.9 million in 2021 to 100.6 million in 2025, and expected to reach 163.8 million by 2033. The CAGR there is 6.3%, so healthy.
6.3%, okay.
Yeah.
Pretty close to the global average then. And the report calls out several key countries driving this, right?
Yeah, the UK and Germany are big players, both starting around like 13 to 14 million in 21,
Yeah.
and projected to get over 30 million each by 2033. France is another major one, starting around 10 million and trending towards almost 22 million.
So significant contributions there.
Definitely. And then you have others. The report mentions Italy, Russia, Spain, all showing steady growth too, moving from single-digit millions up towards, the 11 to 13 million range by 2033.
Even smaller ones like Luxembourg are mentioned, contributing too.
Right. So it's solid, kind of mature growth across Europe, it seems.
Yeah, mirroring that global average mostly.
Mm-hmm.
But if we want to talk about, real acceleration, the report points pretty firmly towards
Asia Pacific, yeah.
Yeah.
The source basically calls it the most rapidly growing region for pyrrole globally.
And you can see why. Look at these numbers. 55.8 million USD in 2021 jumps to 75.3 million by 2025, and then projected to surge to 136.7 million by 2033.
Wow.
The CAGR there, 7.7%. That's, quite a bit higher than the global 6.6.
Okay, 7.7%. That's a significant difference. Who's driving that?
China's at the forefront, yeah. No surprise there, maybe. Their market grows from about 21 million in 21 to 29 million in 25, and they expect it to hit almost 56 million by 2033.
And the reason given.
Massive chemical production base, plus rising pharmaceutical exports, both needing pyrrole.
Makes perfect sense.
Japan's the second biggest market in the region, also growing steadily towards over 23 million by 33. But the real standout growth story, I mean, a major driver globally, seems to be India.
India.
Yeah, the report projects India will have the highest KHER in the entire Asia-Pacific region.
Yeah.
An impressive 9.6%.
9.6%. Wow. Okay. What are the actual values?
Starts smaller, 5.7 million in 21, grows to 8.2 million in 25, but then triples to 17 million by 2033.
Huh. That kind of growth, yeah, that suggests a really rapid scale-up of industries using pyrrole there.
Exactly my thought. South Korea is also a significant player, rising from about 7.6 million towards 18.3 million by 33. Southeast Asia is mentioned as slower growth compared to the rest of APAC, but still growing, reaching nearly 5 million by 2033.
So yeah, it's pretty clear Asia-Pacific, especially with China and India, is like the main engine for this market's global growth right now.
Totally. Okay, moving on to Latin America. The report shows a consistent growth trend there too, right?
Yep, consistent growth. Brazil's leading that region. Its market is expected to go from 4.9 million in 21 up to 10.8 million by 2033.
So, more than doubling. Argentina also showing solid expansion, projected to more than double too. And similar to how Mexico and India stood out, Colombia looks like the growth leader in Latin America.
Yeah, that's right. Colombia's projected CAGR is 8.7%. Pretty strong for the region.
8.7%. Okay.
It's growing from just 0.8 million in 21 to an expected 2.1 million by 33. Again, points to maybe specific industrial developments happening there needing more pyrrole.
Interesting. Specific hotspots popping up. And then finally, the Middle East and Africa.
Right. Smaller market compared to the others, but also showing growth. Turkey leads there. Values rising from 1.4 million in 21 to a projected 3.2 million by 33.
Okay. And Egypt.
Egypt's contributing too, growing from 0.6 million towards 1.4 million. And the report also notes steady expansion for the rest of the Middle East region.
So putting it all together, this regional breakdown, it really paints a picture, doesn't it? A globally expanding market, sure, but with really different speeds.
Absolutely. You've got North America as the current sort of heavyweight, but Asia-Pacific is clearly the engine of acceleration, driven hard by China and India scaling up fast.
And Europe and Latin America showing that solid, sustained growth, each with, like you said, their own internal hotspots, UK, Germany, Colombia.
Even the smaller markets are adding to the total. It's quite diverse.
So what?
This audio was created with podcastle.ai.
Even the smaller markets are adding to the total. It's quite diverse.
So what's fundamentally driving all this growth? The report points to some core factors.
Yeah, it does. It emphasizes rising industrial synthesis, just more chemical manufacturing happening. Then ongoing innovation in healthcare, obviously important for pharma uses, and strong demand from material sciences.
Yeah, those are the core applications we talked about at the start, right? Pharma, agrochemicals, those organic conductors. Growth in those sectors just directly means more need for pyrrole as that basic building block.
Exactly. And looking forward, the report says future growth will be really influenced by a few things, like continuous advances in organic chemistry itself.
Meaning finding new ways to make or use pyrrole.
Yeah. Precisely. Plus rising applications specifically in drug development, which keeps coming up, and also evolving trade patterns across emerging economies.
Right. How materials and chemicals move around the world matters too. So this all kind of loops back to the bigger why should you care question about tracking a market like pyrroles. It's not just about the dollar figures, is it? This data, it's like a window. A fascinating look into where serious industrial and scientific money and effort are flowing globally.
Exactly. It shows you which sectors like new drug development or those advanced materials aren't just growing, but are actually increasing their demand for the fundamental chemical ingredients.
Yeah, it's like seeing tangible proof of tech progress and industrial shifts, just reflected in the demand for this one specific compound.
It really connects the dots.
So, okay, final thought then. Considering pyrrole's really crucial role, which this report highlights, in things like drug development and those cutting-edge organic conductors. What does its projected strong growth, especially that accelerating growth in places like India and China, what does that really tell us? Yeah, maybe about the kinds of technological and healthcare advances we might actually see speed up and, reach us all in the next decade or so.
That's a great question to leave people with. What breakthroughs might be just around the corner, heralded by the rising demand for these foundational molecules? Okay, let's dive in. Today, we're exploring a molecule that's, well, likely a stranger to you by name. It's called pyrrole,
Mm-hmm. Yeah,
but it's silently fundamental to an incredible range of things happening right now.
that's right. Chemically speaking, it's a five-membered ring structure with a nitrogen atom tucked in there.
Mm.
So relatively simple as a building block, but its versatility is, well, it's really quite profound.
And we're unpacking all of this using insights from a source titled The Global Pyrrole Market, Drivers, Restraints, and Trends.
Right. Good source.
Our mission in this deep dive really is to figure out why this chemical, which, might sound incredibly niche, why it's actually such a crucial player in diverse, rapidly evolving industries.
Yeah, what's pushing it forward?
Exactly. What's fueling its growth? What are the hurdles? What's holding it back? And ultimately, where's it headed?
And you might be genuinely surprised where you encounter this molecule's impact. It really is everywhere once you start looking.
Okay, so let's start right there. You called it foundational. Tell us a bit more. What makes it so important beyond just that basic structure?
Well, its importance really comes down to its chemical reactivity and its stability, actually.
Mm-hmm.
That five-membered ring with the nitrogen atom, it acts like a scaffold.
A scaffold.
Yeah, like a core structure that chemists can then build upon or, modify in countless ways. So this makes it indispensable in organic synthesis.
Which is basically creating complex stuff.
Exactly. The whole process of creating complex organic compounds. And like you said, those compounds range from pharmaceuticals, really important medicines, all the way to performance materials for electronics.
Okay, so it's like a critical, versatile Lego brick that complex chemical structures get built around.
That's a great way to put it, yeah.
The source we're looking at, it highlights some pretty significant reasons why the demand for this specific brick, this pyrrole, is really on the rise globally. What's the first major area driving the market?
According to the source, the biggest driver is demand from the pharmaceutical industry. Seems pyrrole frameworks are increasingly being integrated into the synthesis of new drugs.
Interesting. So it's not just used in some drugs. It's becoming like a go-to component in the process of actually creating them.
Exactly. The source specifically notes its expanding use in areas like anti-inflammatory drugs, anti-cancer medications, antivirals. It's becoming quite integral to modern drug discovery efforts, really.
Right.
And you see this global acceleration in medicinal chemistry R&D,
Uh-huh.
especially in, established markets like the U.S., but also alongside rapidly developing economies, think India and China. And that's directly translating into higher demand for pyrrole as a raw material.
That makes sense. The R&D pipeline needs these building blocks. The source gives a specific example related to this, doesn't it?
It does, yeah. It points out that pharmaceutical companies doing intensive oncology research, so cancer research, they heavily utilize these pyrrole frameworks. They're the critical structural basis, what chemists call heterocyclic scaffolds, for many potential drug candidates.
Wow.
So this makes pyrrole a vital upstream chemical. You need it right there in the formulation labs where these experimental drugs are being developed.
So something as seemingly abstract as a five-membered ring molecule is directly connected to, like, the cutting edge of cancer drug research.
Precisely.
Incredible.
Right.
Okay, where else does this molecule show up as a major market driver? What's next?
Well, another key driver is the growing field of conductive polymers and organic electronics. Pyrrole is the primary monomer, the basic unit used to create polypyrrole.
Polypyrrole. Hang on, isn't that one of those plastics that can actually conduct electricity? That sounds odd for a plastic.
It does sound counterintuitive, but yeah, that's its key property. Polypyrrole is one of the leading intrinsically conductive polymers. So unlike typical plastics that insulate, it actually allows electrical charge to move through it,
Right.
which makes it incredibly useful in things like flexible electronics, different types of sensors, and advanced energy storage systems.
Okay, I see the connection now. With the massive push for, smart wearables, flexible phone screens, all those miniaturized electronic devices, you need materials that aren't rigid, right?
Precisely. That whole innovation wave means significant investment in pyrrole-based materials. They're essential for creating things like flexible circuits. You can say embedding clothing or bendable components in tiny devices.
Right.
And the source provides a particularly compelling example here. Medical researchers. They're developing flexible neural interfaces.
Neural interfaces, you mean like connecting tech to the brain or nerves?
Exactly. Devices that can interface directly with the brain or nerves.
Yeah.
And they're increasingly using polypyrrole-coated substrates for this.
Wow. Why polypyrrole specifically for something that complex, that delicate?
It's because of that unique combination of properties. Its electroconductivity lets it carry the signals. And its biocompatibility means it can interact safely with biological tissue. It doesn't cause major rejection issues. So it's a critical material enabling that bridge between electronics and biology.
Wow, from drug discovery to interfacing directly with the human body using flexible electronics, that's quite a range.
It really is.
The source identifies a third significant market driver as well, though, right? A bit more traditional.
Yes. The third driver is its established role in agrochemicals and dyes. Pyrrole serves as a precursor, basically a necessary starting ingredient
Got it.
for various pesticides, herbicides, and also specific types of specialty dyes, including those used widely in the textile industry.
Ah, okay. So back to more maybe traditional industries feeding people and making clothes.
Exactly. As global food production continues to scale up, especially dealing with rising populations,
Right.
and as textile manufacturing undergoes rapid expansion, particularly across the Asia-Pacific region, well, the demand for these pyrrole-derived products naturally rises too.
Makes sense.
The source actually highlights countries like Vietnam and Bangladesh, where their booming textile export industries are directly leading to a steady increase in the consumption of pyrrole for making dye intermediates.
It really does underline how a single chemical, something most people have never heard of, can be fundamental to such diverse aspects of our lives. You've got potentially life-saving medicine, futuristic, flexible tech, all the way to the agriculture that feeds us and the clothes we wear.
It's quite something.
But, okay, this market isn't all smooth sailing, is it? What are the main constraints? What are the hurdles the source points to?
Yeah, definitely not smooth sailing. One of the primary challenges outlined is the inherent toxicity and hazardous nature of pyrrole itself. This significantly complicates how it must be handled, transported, stored, the whole logistics chain.
Okay, what makes it particularly difficult or dangerous to work with?
Well, it's known to be volatile and flammable, and improper exposure can pose serious health risks to workers. Because of this, extremely strict safety protocols are absolutely essential throughout its entire life cycle, really, from manufacturing right to the end use.
And those protocols cost money.
Exactly. Implementing them directly increases operational costs. And this can be a particularly heavy burden for smaller manufacturers, especially maybe in regions where regulatory oversight or infrastructure might be less developed.
So the very properties that make it reactive and useful also make it tricky and expensive to deal with safely. Okay? What's another constraint on the market?
Another major restraint is the volatility of raw material prices. The source specifies that the key raw materials used to produce pyrrole are typically acetylene and ammonia.
Acetylene and ammonia. And where did those usually come from?
They're often sourced from petroleum, fossil fuels, basically.
Ah, okay. There's the link.
Yeah. This creates a direct link between the cost of crude oil and the economics of pyrrole production. So any disruption or significant swing in global crude oil prices, like geopolitical events, supply chain issues, that can make pyrrole production economics quite unstable. It leaves profit margins really
This audio was created with podcastle.ai.
economics quite unstable. It leaves profit margins really vulnerable to these big external shocks.
So events halfway around the world affecting the oil market can ripple all the way down to the price and availability of this specific chemical.
Absolutely. It's all connected.
What's the final restraint mentioned in the source? Seems like there are a few significant ones.
The third one is environmental concerns. And alongside that, increasingly stringent regulations. Regions like North America and Europe in particular have really tight emission regulations that producers absolutely must adhere to.
Okay, and why is pyrrole production particularly sensitive to environmental regulations? Is it the process itself?
It can be, yeah, because the synthesis process and then later the disposal of intermediate products or byproducts, they could generate hazardous waste.
Not good.
No. So tighter environmental laws mean producers must invest heavily in often costly pollution control systems, waste management systems, just to ensure compliance. And this, again, directly increases operating costs, particularly in those heavily regulated markets.
So, despite being essential, pyrrole faces these significant challenges. safety issues, the fluctuating cost of its oil-based ingredients, and the environmental impact of making it.
That sums it up pretty well.
But even with those hurdles, the source suggests the market isn't just, stuck. There are clear trends shaping its future trajectory. What's one of the key trends pushing things forward?
Well, a major trend is the deepening integration of pyrrole-based materials into organic electronics. We touched on this, but it's really accelerating, particularly in those rapidly evolving areas like smart textiles and wearable sensors.
Right. This brings us back to that polypyrrole we discussed earlier, the conductive plastic.
Exactly. That unique combination of polypyrrole's flexibility, its biocompatibility being safe for biological systems, and its electrical conductivity. That's making it a material of choice.
It's like the perfect storm of properties for certain applications.
It really is. It's perfectly suited for these emerging applications where, traditional rigid electronic materials just won't work. They'd break or they wouldn't conform to the body. The source points to innovations like self-healing materials.
Self-healing, seriously.
Materials that can repair minor damage themselves, and e-textiles fabrics with embedded electronics. These are increasingly relying on pyrrole and polypyrrole as core components.
Self-healing materials in clothing. Wow, that truly sounds like something out of science fiction, enabled in part by this chemical. What other trends are highlighted?
Another big one. There's a significant and growing push towards green chemistry approaches for actually making pyrrole.
Ah, okay. More sustainable methods.
Exactly. Chemical companies are actively exploring more environmentally friendly production methods. They're specifically looking into things like catalytic routes, which can be more efficient, and bio-based routes.
Bio-based. So potentially moving away from those petroleum-based ingredients like acetylene and ammonia, maybe using biological processes.
Precisely. The goal is to find methods like, say, enzymatic synthesis, using enzymes as catalysts, or using renewable feedstocks, maybe derived from plants, instead of those fossil fuel sources. And the objectives are pretty clear. Lower the environmental footprint of pyrrole production, make it cleaner, and also reduce that dependence on volatile, non-renewable raw materials like oil.
That makes a ton of sense. It aligns perfectly with broader global sustainability goals you see across almost all industries now. What's the final trend mentioned in the source?
The final trend the source highlights is all about strategic partnerships and innovation that's driven by intellectual property or patents.
Okay, so companies teaming up.
Yeah, you're seeing increasing collaboration between chemical manufacturers, pharmaceutical firms, and academic research institutions. Universities doing foundational research.
And what are these alliances trying to achieve? What's the goal?
Well, they're focused on developing and then patenting novel pyrrole derivatives.
Derivatives, so slightly modified versions of the basic molecule.
Exactly. Tweaked versions that might have enhanced performance characteristics. Maybe it's improved electrical conductivity for electronics or better biological activity for drug applications.
Ah, tailoring it for specific uses.
Right. For example, the source mentions pharmaceutical companies partnering with chemical researchers, specifically to patent new pyrrole compounds that are tailored for precision medicine applications.
Very targeted. And I assume electronics manufacturers are doing something similar, protecting their innovations.
Absolutely. They're securing intellectual property, filing patents around advanced pyrrole polymers that are designed for seamless integration into the next generation of smart devices.
Makes sense. You innovate, you want to protect it.
Right. And these kinds of strategic alliances and the resulting patents, they're crucial. They significantly accelerate product development cycles, get things to market faster, and they provide the companies involved with a real competitive advantage in these high-value sectors.
Okay, so let's try and connect this back directly to you, our listener. Why should this molecule, pyrrole, why should it matter to you? It sounds pretty technical.
Well, I think it matters because it's this invisible but essential thread running through so many aspects of modern life that you encounter every single day. It's a fundamental building block enabling advancements in medicine that could, treat diseases. It's powering the flexible electronics revolution, the wearables of potential medical devices, and it's contributing to the production of your food and clothing through agrochemicals and dyes.
So it's kind of hidden infrastructure.
Exactly. And this deep dive into the pyrrole market serves as a powerful example, really, of how these complex global markets for seemingly obscure chemicals actually underpin major technological and medical progress.
Right.
And understanding its challenges like the safety issues, the environmental impact, and its future trends like green chemistry, this targeted innovation, it gives you a window into the dynamic forces shaping industries that are most relevant to your life, even if you don't see the pyrrole itself.
Okay. So to sort of summarize then, we've seen that pyrrole is this vital molecule. Its market is fueled primarily by pharmaceuticals, organic electronics, and then sectors like agrochemicals and dyes.
Right, big drivers.
But it grapples with significant challenges. Its hazardous nature, toxicity, the raw material price volatility because it's tied to oil, and the environmental impact of its production processes.
Definitely key hurdles.
But despite these hurdles, the future holds, well, some pretty exciting potential, right? Driven by trends like its deeper integration into cutting-edge organic electronics, that growing push towards more sustainable green synthesis methods,
Which is huge.
and strategic innovation through these cross-industry partnerships, focusing on those proprietary derivatives, those tailored molecules.
Yeah, the outlook seems positive despite the complexities. The source material concludes that even though companies have to navigate regulatory complexity and safety concerns, the pyrrole market is actually quite well positioned for robust long-term growth.
And that's largely thanks to this rising R&D activity we talked about and the collaborative efforts across different industries.
Exactly. What's particularly thought-provoking, though, is considering pyrrole's essential nature and its inherent hazardous properties.
Yeah, that tension.
Right. Combined with that accelerating trend towards green chemistry and sustainable production, it raises a big question.
Okay, so this leaves us with a question to ponder, drawing directly from the implications of this source. Given pyrrole's foundational role, how absolutely vital it is, and the environmental and safety pressures on its current production methods, what breakthrough innovations might we see that could fundamentally change how this crucial chemical is made and used in the future? Perhaps making it dramatically safer or truly sustainable.
This audio was created with podcastle.ai.